Hello everyone, welcome to this video. In this video we solve this question which states that suppose that H is a non-empty subset of a group G with the property that if A and B belongs to H, then A inverse B inverse also belongs to H. So we are given this property that A and B belongs to H implies A inverse B inverse belongs to H, correct? This is the property. So here we need to check that, to check whether H is a subgroup of G or not, subgroup of G or not, right? So here in order to do that, we will check. So to check this, we will check that for the elements A comma B belonging to H, if A inverse belongs to H, right? And we will also check AB belongs to H. So using this subgroup test, we'll check if both the conditions are satisfied, then our this subset H would be a subgroup of G, otherwise not. So, and we have to make use of this condition only. So here in this particular case, we know if H is a subset of G, it would surely contain the identity element within it, correct? So it is non-empty subset of group G, so that means it would surely contain identity element. So let's take E belongs to H, right? And let's take A belongs to H. So this would imply E inverse A inverse belongs to H. So this would imply the inverse of identity is identity itself, right? So it implies A inverse belongs to H. So that means if A is present in H, its inverse is also present in H. So it satisfies this first property, correct? Moreover, as A and B belongs to H, right? A belongs to H, this implies A inverse belongs to H, and if B belongs to H, this implies B inverse belongs to H by the above reasoning, right? By the above reasoning. So if this A inverse and B inverse belongs to H, so this would imply if A inverse and B inverse belongs to H, right? So from this we know if A and B belongs to H, right, it implies A inverse and B inverse also belongs to H. So this would imply the inverse of A inverse into the inverse of B inverse, which is A and B also belongs to H, right, according to the given condition, by the given condition. Hence we have satisfied both the properties which are required in order to prove that it is a subgroup. Hence we say H is a subgroup of G, correct? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.